So in the past video, I introduced some key terms in geometry, and those were your rays, your line segments, and your three undefined terms. If you don't remember them, you can always go back to the previous video, link in the description. But today I have an interesting title for the lesson. As you can see here, it's called Pool Room Math. What am I talking about here? Well, I want to give you guys a real-world example. And here I've drew a little figure here, and what I've done here is I have made an outgoing, this is an incoming actually, your original line or array actually, and this would be your outgoing. And the way, this is like the cushion of the pool board, of course. I don't know anything about pool, but I know how angles work, so give and take. So anyways, when your ball moves in this direction and then it bounces off and goes in the other direction, you're forming angles. And I'm trying to show you that angles are used extensively in real-world applications actually. You have an entire branch dedicated to it. It's called trigonometry. And we're going to go in trigonometry in the end of this, or towards the end of this geometry series. And we actually have a section dedicated to it, a huge section dedicated into it as we move on into pre-calculus, which is a series that I'm thinking about whether I should do it or not. But anyways, here we have this idea of angles, and I want to teach you guys what an angle is composed of. As you can see here, it's composed of two rays. So two rays, and the endpoint at which they meet, so let me give you an example. These would be your two rays. Let's call this ray BE, and this ray ET. And this, of course, would be called the vertex, and the point at which they meet, alright, so where the point they meet is the vertex. And I'll show you guys where the vertex is on these three examples that I have on the top. This vertex would be here. You know, these are two different rays, and the point at which they meet, the end point actually at which they meet, would be this point over here. Let's call that point J. Alright, point J, and I'm going to actually erase that, so we can move on to different examples. On this one, it would be E, right? Point E. We went over that. And on this one, whatever the vertex would be here, right? And also what I want to talk about are the idea of naming these angles. And naming these angles are really important. So there's a specific pattern that we use, and it'll be side, vertex, side. Or it could be your side prime, vertex, side prime. Okay, this might be a little confusing, so I'll cancel that out. But what I'm essentially saying is that your vertex has to stay in the middle. Oh, is this triangle? My bad. Sorry, I meant angle, guys. A G, big difference. It's like a sideways triangle. Okay, so what I'm saying here is that your vertex has to stay in the middle when you name it. So if I were to name this, what do you think it would be? We have two possibilities that we can name it, but one of these letters has to stay in the middle. What do you think it is? Well, in this example, E has to stay in the middle because it's the vertex. So vertex always in the middle, remember that. So we can say BET, or we have another possibility. You can say TEB, and so let me switch to a different color, TEB, but we know that this E is always constant. It looks like a sigma, TEB. So E and an E. Alright, well, what else should we talk about? Actually, I should talk about measuring these angles. How do we know what they are? How do we know that these angles, how they're measured? They're measured in a unit called degrees. You've probably heard of this before in your, well, early math classes, say in elementary school or early middle school. So let's say we have this. Let's say this is a protractor, right? This is obviously not the case. We're going to have a 0 end and a 0 end. What we want to do, assume that this is our angle. So we want to match up the 0. That's not a good example. We want to match up this 0 with one of the rays, or one of the rays. And then we measure the other part of the other ray using the angle measures or the degree measures. Let me show you an example of that. So this is a protractor that I pulled off Wikipedia, and you can see here that has different angle tick marks. And you can see here also that has different tick marks for blue and black. Well, why is this Why is it in this case? Well, if you measure your angles, you notice that you have either an option of 0 or 180. If you choose to measure 0 on this end, on the blue end, then you're gonna have to stick with the blue end. If you choose to measure on this end, this left end here, which is the black end, you're gonna have to keep being consistent with that black end. So, for example, if I were to put our 0 degree mark, something here, along this blue mark, say, oh, escaped. But anyways, you get the idea. If we're measuring from this blue end right here, then we're gonna have to measure this with the blue end as well, not the black end. You cannot mix and match. Sorry about that. And also, I want to talk about congruence, and we're gonna wrap this video up in a few minutes. So we can say that triangles are congruent if they have equal measure. And what do I mean by that? Well, equal measure, I mean they have the same amount of degrees. That's all there is to it. So obviously this is a very weird figure, this gray figure right here under this red one, but if I were to say they're congruent, you can believe me because I have a loop and a mark. And a loop and a mark, what it means is that angles are congruent. So if I have another one here to match this one, and we were to say these two angles are congruent, all we have to have in this loop is put a little mark right there. And that's how we know that the angles are congruent.